/NumPy pandas. So I'm going to call this p4d dash NumPy dash pandas. So this is just to say that this file today we'll be treating NumPy and pandas. And so okay, so let me bring in what we want to start with. So introduction to NumPy. All right, so here, if I copy this, once I copy this, I want to change this cell to a markdown. So this way, I don't have to use the comments method, and it shows automatically when I run it. It makes it much more cleaner in terms of what we have, and then we can understand. Are we all together?
Yes, we are.
Together. All right. Okay. Good. So NumPy. What exactly is NumPy, and what's the need for it in data analysis? So in basic terms, NumPy is a Python library that is used to perform algebraic operation. So when I say algebraic operation, I mean mathematical or any scientific or statistical calculation, anything calculation. NumPy is our best guide to do that. But it is not only limited to calculation. Let me open this because I think I'll be explaining something from that part. So it is not only limited to calculation, but it is a library that helps us perform calculation easily on all of the different data types that we have, or data structures that we have. And it also makes it very easy for us to handle data in any part, like any type of data. So we'll see how NumPy handles data, because now all of the items all of the values that we have, everything is data in its form. That's why, if you remember, we called the various type of data that are stored in a variable data. So it is data type, because all of these things that are being stored inside are seen as data. I hope we are getting that. So now, why is it important for us to know NumPy in data analysis? Now, it is very important for us to understand NumPy and know how to use it, because of the extensions that come with it. And it also makes, like I said, mathematical calculations easier for us to do. So yesterday we talked about, for instance, when we want to perform power operation. So when we want to perform power operation, we say 2 * 2, right? And that gives us 4. That is 2 raised to power 2. But when, instead of doing all of this in terms of 2 * 2 for power, we can use an extension or a function in NumPy called power. I'm going to show us how that works as we go on. If you want to perform square roots, how do we perform square roots in normal, what's it called, normal Python calculation? We would use something like 4 * 0.5, which is 4 raised to power half. So when we run this gives us 2. So this is more like the square root of 4, right? But how do we handle things like this when we use NumPy? NumPy has something called square root, sqrt. So all of these are sometimes if you do 4.sqrt, or let me say sqrt 4, it does not understand it. It would say sqrt is not defined. Do you see? And although there are libraries that we can use, for instance, we would have to do something like import maths, and then from import maths we can then start to work. But we don't have to always do this, because you would have to import a lot of libraries when you do things like this: import math, import random, import different libraries. But with NumPy, everything is inside one library, so it makes it easier for us to do all of that. So let's start. How then do we use NumPy? That's the question. Next question. How do we use NumPy? To use NumPy, we would have to import the NumPy library itself. Now, to import the NumPy library, we say import. So import is a function in Python, like we said yesterday. Anything that we write in Python, once it changes the color to green, it tells us that it is a keyword in Python, apart from numbers. So import, so we say NumPy. So when we say import NumPy and we run it, it would automatically run. But we don't always want to write NumPy every time we are working, like we are writing our codes. So we want to abbreviate NumPy. So we say as NP. So this means that anywhere we write NP, it is identifying NumPy, just the way we explained yesterday using variables, where a variable stores a particular item, particular data. So, but this time around, our variable name is NP, and we are saying that it should store the name or the library called NumPy. Are we together? So to use NumPy, we say import NumPy as NP. Literally, we can even say as anything, but NP is used because it's kind of flows with NumPy. NumPy, we get the flow. So when we say we run this, it takes some minutes and then it runs. Now, if we don't have NumPy on our system previously, it's not going to work. And that was why I told us days before we started our class that we should import certain libraries, and NumPy is one of them. So how do we now use NumPy? So when we type NP and we press dot, and we press tab on our system, if you look at this place, this beside IP kernel, the color changes to black when it is loading, and then when it is done loading, it changes back to white, and we can see all of the extensions that we can have inside NumPy. Are we together?
So where did you click to get all these options?
Okay, so yes, I said, let me go again. I've imported NumPy, right, as NP. Now I say NP and I press dot and I press tab. On my keyboard, there's a tab on my system. On the keyboard of your laptop, you have tab there. So once you press tab, it's going to load for a while, and then it's going to bring out all of the extensions that you have under NP. All of these extensions are functions that are inside it. For instance, if you have absolutes, you have abs, you have add, we have adduct, we have a lot of extensions. All of these extensions, like I said, are functions already designed, already defined inside of NumPy. Each of them have what they do, but we will not be taking all of them. We don't be talking about the major ones that we would be using as time goes on. And then as time goes on, we'll be getting familiar with some of the other extensions. So now, these are some of the extensions that we have, and we can also use them to perform certain.
When I did what is it called now? Import NumPy as NP. It's showing me cell in one. Import NumPy. It's showing me error, syntax error.
Look at your case, the case of your of what you've written.
Okay,
they should all be small letter.
Small letter.
Is that fine?
Oh.
Yeah. Okay. So so now I showed us some of the extensions that we can have, and so now let's look at how we can use some of the extensions. So let's start with the basic.
It's not showing me, sorry for cutting. It's now showing me no module named NPy.
No module named NumPy. Did you import NumPy in your Anaconda prompts the last time?
Yes, that pip stuff. Yes, it showed me already installed.
It showed you already installed. Then it should work. If it's not working, something is wrong from your system. It should work.
Let me try it again, though. You can continue. Let me try it again.
Okay, so now let's perform one of the basic operation that we performed in our previous class. Like, what was the basic one we did? We did raised to power, we did addition. Yeah, okay, so let's perform basic operation. The basic operation, first one we have is add. So I say np.add. Now, if I want to know how an extension works, how a function or an extension works, I come inside of it and I press Shift Tab. When I press Shift Tab, it gives me a detail of how that function is working. So I can press this show current doc string in pager, and then I'm able to see how certain things work in it. So it says add takes parameter x1, x2, out is none, where is true, casting is true. All of these things, we really don't need much of them. So let's scroll down a bit and then we see add argument element wise. So what does it do? What it does is it adds argument. So it adds two things together. So if I have x1, x2, or an array like object, what it does is it adds them together. So when I want to understand how it works, I scroll down a bit and I come to example. So in my example, what do we see? We see np.add 1.0, 4.0. What does it give? 5.0. So it means that this np.add function that we have adds two numbers together. It adds 1.0 and 4.0 together. Now, let's now go down a bit and see what it does again. So if we have x1 as np.arrange 9.0, I'm going to explain what np.arrange is later on, and in the next functions that we'll be talking about, and np.arrange 3.0. Now, what does it do? It says np.x1, x2, and then you have all of this. So what this literally does is it adds even an array objects, it adds them together regardless of the data structure it is. So now we see it says here the plus operator can be used as a shorthand for np.and on nd array. This is n dimension arrays. So we've seen the example, so let's try to like play around with it. So I'm going to close this and we say, so let's say np.add 2, 3. So this should give us 5 because it says 2 plus 3. Are we together? Are we getting it?
Sorry, I would have loved to follow you, but this NumPy, I don't know. The pip thing you said we should install, I did it and I'm still getting error. And it's showing me already installed already.
Okay, 1 minute. Can you share your screen?
Yeah.
Okay.
I'm coming. Can you see my screen now?
Yeah, I can see your screen.
So look at this. This is for NumPy. Is this not what
Yes,
you're supposed to? Okay, so
yes,
this
I've
is
seen it. So you can just go to you. Yeah.
look at what you're
Your
showing.
NumPy, yes, your NumPy is capital letter. Like I said, it is supposed to be small letter.
Oh,
Yes, so when you run that now, it works. Yeah,
oh,
so that's it. So like we mentioned yesterday, for us, Python is case sensitive. All of the libraries, no, I can't say all. Don't let me say all. Most of the libraries in Python are in small letter. There are some libraries that are in capital letter, but it's even those libraries itself, they are yeah, there are some, let me say, functions in Python that are in capital letter, like inbuilt functions. So, but then most of them are in small letter. So let's we should take note of that when we are working. So let's
thank you.
continue. Yeah, you're welcome. So when we do np.add, it shows us, it basically performs an add operation, an addition operation, 2 plus 3. Same thing if we do np.add 100, 988 or 989. When we run it, it shows 1,800 1089. Now, this we can literally use it when we are creating certain functions or when we are creating certain programs. So let's try something. Let's try to do something here, and you would understand how it works. So let's create a system where the user inputs a particular number and then it adds the numbers together. But here we want to use NP. We are not using the basic x plus y. We want to use np.add and we'll see. So let's say, for instance, x equals to integer. We want an integer input, and we say enter a number. So we say enter a number for x, and we say y equals to input, same thing that we want to do. So I don't just copy another, Control V, and then here I say np.add x comma y. Are we together? So when I run this, for instance, it says enter a number 12, enter another number 90. When I run it, it says 102. So we'll see now how we are able to use NumPy addition of function to perform an addition operation. So let's go to another operation that we can have. So we can have np.subtract, which is another function in it. Same structure. But now, how does the subtract work? The subtract also works the same way. But this time around, the first value you have, or the first parameter you have, is what it will subtract from. So if we say 3,5, we should get -2. Are we together? So that is because it says 3 minus 5. Please give me a minute, please. Let me just switch. All right. So this says 3 minus 5. So same thing, we have np dot multiply. It does the same thing if we have 5,6, and it does this. Now, one of the things that we would want to ask ourselves is, can I perform multiple operation? For instance, when I have 2 plus 3 plus 4, this is 9. Now, can I do that with NP? Because these are some of the other things that we would also want to think of. So if we look at it, for instance, np.add, and we say 2, 3, 4, it says an error. This is what return array must be of array type. Now, this is because these functions that we have, they follow a particular procedure. Like we showed ourselves the other time, which is it follows the procedure x, x1, x2, which is you only have 2 parameters for it to work. If you have beyond 2 parameters, you would have to perform each of the operation one after the other. So these are some of the things that we also need to know with regards to using these functions. Now, so we've done multiplication, so let's do one more, which is divide. And here we have, let's say 6 divided by 3. Oh, sorry, 6, 3. So when we run it, it says 2.0. Now, we also showed ourselves modulus yesterday, which was modulus is, what do we say modulus is again? Modulus is integer remainder of division. Now, how do we perform things like that here? So we use np.div mode, and then we say, so let's say 3, 2. 3, 2 would give us 1. So here it says what? 1, 1, which is 2 will go in 3 ones, and then there will be one remainder. Are we together? So let me show us another example. So let's say 9, 2. So when we run 9, 2, it should give us 4, 1. So this tells us what? 2 will go in 9 4 times with one remainder. So these are some of the ways that all of these operations are done. Now the next thing we want to show ourselves is np.power. So when we scroll down here, we have power. So power, what does it do? Power literally takes, so let me just show us what it does. It takes 2 arguments also, and then when we come to our example, where is yes. So let me just continue here. So when we come to do example, so let's say 4, 2. So 4, 2 here means 4 raised to power 2. So when we run this, it gives us 16. So so this is one way this is done. Now, what about if I want to take a square root? So I can say np dot. So when I come here, I do sqrt and I write 16. So this would run square root of 16, and this should give us 4. So now we've seen some of the basic mathematical operations that we can do using NumPy. Now let's now move to the advanced part of some of the things that we can do. Now, yesterday we talked about
in line 10. In line
Yes.
10, if we actually want to perform this operation that says 2 plus 3 plus 4, how do we do it?
So if you want to perform an operation like 19 in NumPy, using NumPy, what we would do is we would have to do it one after the other. So we would say x equals to np.add 2, 3. And then we come to again in the next line, we say np.add x, 4. So now what this would do is it would add 2 and 3 first, put it inside x, and then take what is inside x and add it to 4. So now when we run this now, it gives us 9. So that was why I said that the add function and all of these functions that we have, you cannot perform them using NumPy like on more than 2 more than 2 parameters, because each of the functions that we have inbuilt in NumPy can only take 2 parameters for them. So for instance, you cannot multiply 5 times 6 times 7. If you do that here, it will tell you an error. But for you to be able to do that, you have to take 2 of them first, and then when you are done, you add you multiply again with another number. Do we understand that?
It's clear.
Okay, so now we would see here that the usage of variables now really helps a lot when we do things like this, because now we are able to we are not just able to assign just numbers, but we are even able to assign operations, because this is an addition operation. We are able to assign operations to a variable, and then we are able to see that a variable is not just limited to just single numbers. It can take operations inside it, and as we go on, we'll be able to see the power of using variable even for complex operations. So now we talked about list yesterday, and then we saw some of the things we can do with list. But before we get into lists, we used something called range yesterday, and then we saw how we can use a range of numbers. So we say range of 5, it gives us 0 to 5. So if I make this a list, for instance, it gives me 0, 1, 2, 3, 4, 5, right? Now, we have this is a list of numbers in range in normal Python. How do we do things like this in NumPy? For us to do this, all we have to do is call a function called arrange. So there is np.arrange. Now we'll see that arrange has only one R and not two R from our basic like English. So these are some of the things that we need to note when we are working. And so we say arrange. Now, how does arrange work? So let's go. We'll see here it says start. So there is a start number, there is a stop, a comma, and there is a step. After that, we have data type. So we can state the data type that we want, and we can also state like and every other things. So let's make it easy. The start. So it says a start. Where do we want to start from? Now, we want to start from, let's say, 101. So we want to create a list of numbers starting from 101. And where should it stop? We want it to stop at 120. So we want to have numbers from 101 to 120. So when I run this now, it gives me an array, which is also like a list, because we'll see here inside it, it has a square bracket. And I told us yesterday that for us to use a list, we use the square bracket. So it has a square bracket inside it. Now, we'll see that it creates numbers from 101 to 119. Now, why did it stop at 119? Now, Python has an inbuilt rule, which is any number you want to stop, any index you are using to stop, it stops at the number you have stated minus 1. So if I say, same thing we see here when I say, give me the range of 5. So it goes 0, 1, 2, 3, 4. It gives me 5 items, but it stops at 4 and not 5, which is what I've stated here. So same thing goes for if I say, for instance, give me a range of 50 to 60. It's going to stop at 59. So when I do a list here now, list all of these numbers, it gives me from 50 to 69. So which shows that the limit that it goes on the upper bound is n minus 1. So we need to take note of this. Now, I have used an arrange at the arrange function to create a list of numbers, right? So I've used the array to create a list of numbers, but this list of numbers that I have is not a list, it is an array. Now, what is the difference between a list and an array? So let's do something. So let's come here. I want to do this now. I'm going to call this arrange function that I've used, I'm going to call it array. I'm going to call it array, right? Are we together? I'm going to call E here. So I have created a variable called arr, and it is holding numbers from 101 to 119. Now, I want to do the same thing for lists, 101 to 120. And I want to call this, okay, let me call this, I'll call this LST. I'll call this LST. And so if we look at what we have here, we have two, we've run two scripts now. One of them is using the NumPy function of creating an array from 101 to 120 in form of a list. So this is an array, a list inside. So this is an array. Now we've created a list that has what number from 101 to 119 also. But this time around, you see that when I run it, it does not arrange the the numbers in a kind of structured way. It literally lists each of them one after the other. This is to show us how a list handles number in terms of visualization and how an array handles them. Now, but this is not just the difference between the array and a list. Now, what exactly is the difference between them? Now, the difference between a list and an array is that you cannot perform what's it called, arithmetic operation on a list. You know, I showed us here, we showed ourselves yesterday where we tried using multiplication and addition on lists. When you do this on a list, when you use multiplications, the multiplication sign on a list, it duplicates what is inside it. But when you try to add, it does not even work at all. Now, same thing occurs here. Let's try to see what would happen. So when I come here and I say 2 plus LST, it's going to give me an error. So the error says that what? Unsupported operand type for plus, integer, and list. So this means that I cannot add an integer with a list. Now, well, let's try to do that with an array and see. So we have 2 plus ARR. So when I run this, what does it do? It literally adds 2 to all of the numbers that I have inside ARR. Are we together? Are we together?
Yes.
Continue, sir. Continue,
Okay.
sir.
So now we see here that we cannot perform arithmetic operation on a list. From, like, you cannot perform arithmetic operation from an integer to a list, but with an array you can perform all of this. You can perform operations like this. Now, same thing goes to multiplication. So when we do 2 times list, it is going to duplicate everything that is inside, like from 1 to 119, and it goes all over again. But when we do this for an array, say 2 times ARR, what does it do? It multiplies 2 with all of the numbers in ARR, which is 101. So 101 times 2 is 202. 102 times 2 is 204, all the way down to 200 and what did we have here? 19. So 119 that we have here.
Excuse
So,
me.
yes.
The 2 times list, what did it return? Did it return the same set of numbers?
Yeah, it returns all of the numbers, but then it duplicates it. So we have 100,
Okay,
101 to 119.
okay, it replicated it.
Exactly.
So I was looking out for it to give an error.
No. So like we stated yesterday, when you do when you use the multiplication sign with a list, you know, this was a list, this student age was a list yesterday that we created. So when you use the multiplication sign with the list, with a list, like a data type list, what it does is it duplicates what is inside all the way, like what you have 10, 13, 14, 12, 14, 10, it duplicates it again. If I should do this and say 3 times student age, it's going to do that 3 times. You get it? But when you do that with an array, what it does is it multiplies, like it performs an actual multiplication operation on the items inside that array. Are we getting it? So we see the difference between how a list handles arithmetic operation and how an array handles arithmetic operation. Now, how then do we perform arithmetic operation with a list? Now, for a list to perform arithmetic operation, you need to do it with another list. Now, there is a rule. The rule is the list that you are performing the operation on must have the same dimension with the first list. So let me show us what I mean. So we have LST. LST is 101 to 119. So let me create another list and say list. Let me just call this list 2, and I say equals to, let me just say 1, 2, 3, 4, 5. Yeah, I want to stop 1 to 5. Now, this is a list, right? This is a list, and we have another list called LST. Now, when I try to say list LST plus LST underscore 2, what does it give me? we'll see here that the plus sign does not perform an arithmetic operation as we expected. What did it do? It literally added 1, 2, 3, 4, 5 inside the list. So it did not add the numbers. It added the items inside the first list into the second list. So that's not an arithmetic operation. Are we together? So now we'll see that we cannot really perform an arithmetic operation with a list. But let's create another array called array2. And then we have, so let's say np dot arrange, and then we say 5. When I do 5, it's automatically going to start from 0 to 5. So from here, for instance, I don't have to always create like a stop. So now when I do this and I call arr2, I have 0, 1, 2, 3, 4, right? Which is okay, here I created this. Okay, so let me just create this as a list. So okay, let me come here. So array, inside it I want to have 1, 2, 3, 4, 5. So when I do this, I have an array of 1 to 5, right? So when I do arr plus arr2, what does it do? It says that an operand cannot be broadcast together with shape 19. So this has 19 rows and this has 5 rows. Now it means that if you want to add 2 arrays together, the 2 arrays must have the same shape. Are we together? So let's create an array of the same shape and see what would happen. So let me call this array3 so that we are able to follow. And I say np dot arrange. I just want it to give me 20. I say arr3. So this goes from 0 to 19. Now when I want to see the shape of what is here, this array3, I can say arr3 dot shape. So we see that there are 20 items, so I want 19. Sorry. Okay, yes. So when I do dot shape here, I have 19 also for arr3. Now I can say arr plus arr3. So when I run this, what it does is it adds each of the numbers. So it's going to add 0 and 101, 1 and 102, 2 and 103, 3 and 104. And that's exactly what we have here. So now we are able to understand how we can perform arithmetic operations with a list. With an array. Now, what about division? Now we can perform division operation 2 ways. We can perform it in terms of a single number. So I can say arr divided by 2. And when I do this, it's going to divide each of the items inside the list, the array that I have by 2. Now, if I want to also divide each of them by the items I have inside this array, I can say arr divided by arr3. So when I do this, it goes 1 divided by 0 is infinity. 102 divided by 1 is 102. 103 divided by 2 is 51.5, and then it goes like that. We'll see that there is a trend in terms of how it goes. So the numbers keeps going down from 102 goes down to like 6.6. So we kind of see how we can perform division operation with arrays. Now, all of the things that we've been doing so far are one-dimensional array. One-dimensional array means that we have just rows. Are we together? We have just rows. How do we now work with columns, or how do we have how do we do it such that we have rows?
Hello, sir.
Yes.
Please, can you repeat that thing, line 44? Because I was thrown out by network just now. Sorry, sir.
Okay. So I said When we want to perform arithmetic operations with arrays, we can do them two ways. We can perform arithmetic operations with only integers, like just a single number, or we perform arithmetic operation on the array using another array. So I explained that we have array ARR, for instance, is 101 to 119. When I want to perform an operation using a single number, all I just have to do is ARR divided by 2. This would mean that each of the items inside ARR should be divided by 2. So it goes 101 divided by 2, 50.5. 102 divided by 2, 51. 103 divided by 2, 51.5. It keeps going on and on like that. Now, the other way is to perform the arithmetic operation using another array. We know that ARR3 is 0 to 19, like we have here. So what I did here is I said ARR divided by ARR3. Now, we remember that it tells us here that an array would not perform an operation unless they have the same shape. So here it did not perform this operation because ARR2 has 5 items in it inside that row. Meanwhile, ARR has 19. So both of them have to be of the same shape, basically. So here now what it does is it says ARR divided by ARR3. So it goes 101 divided by 0, infinity. 102 divided by 1, 102. 103 divided by 2, 51.5. 104 divided by 3, 34.67. 105 divided by 4, all the way, it keeps going all the way down till it gets to the end. Now, this tells us that we can perform division operation on an array using another array as long as they are of the same shape. Are we together? As long as they are of the same shape. So that's the rule. Now, like I said, all of the things we've done so far, when we look at ARR and we say shape, we see that it has just a rule. It does not have colon next to it. It says comma and nothing is beside the comma. Same thing goes for, so if I run, let me just do print ARR 2.shape and ARR 3.shape. So .shape in function, what it does is it gives us the structure of what we are working with. Now, this .shape function comes with NumPy. You cannot use it with a list. So we created a list the other time. What's the name? LST. So I cannot say lst.shape. You can see it says list object has no attribute shape because this list itself is not from it does not have the function, it does not have the attribute shape inside it. So these are some of the things we need to note when we work with NumPy. So all of these attributes that we have, all of these functions are things that come with NumPy itself. Now, when we see all of this shape that we have, it only has rows. There are no columns in it. How do we then have columns created with our data so that we are able to work on actual data in terms of rows and columns? Now, this would take us back to how we created an array in the first place. So when creating an array in the first place, we created it using one single, what's it called? Square bracket. So when we have np.array, you have only one single square bracket. We have 1, 2, 3, 4, 5. And when you run this, it's just going to give you an array of 1 to 5. Now, if we have 2 square brackets, so we have, let me come here, 2 square brackets. Now, it means that one square bracket is inside another square bracket, right? So this is going to, so let's put 1, 2, 3, 4, 5. Now when I run this, we have, this is also a list, don't forget. But now I can convert this to an array. But when I do that, let's see what's going to happen. So firstly is, before I do that, let's see the shape of what I have here. This one that has one single quote, one single square bracket. I mean, so when I do dot shape, it has 5 comma and there is nothing beside it. Now when I create an array, np.array, using 2 square brackets, let's see what it's going to show. It shows an array of this. Now let me now check the shape of this, and I say dot shape. What does it say? It says 1, 5. Now what is the difference between what I have here, in terms of np.array using one single square bracket, and when I have np.array when I use 2 square brackets? Now the difference is that the square bracket literally defines the number of rows and the number of columns in it. That's just what it does. So here I have no, I just have just one row. So it's just one row and each of them are columns inside. Now, why here I have one row and 5 columns inside, compared to this that just has like, just, it sees it as 5 rows instead of 1 row per item. Now, how do we now create multiple rows inside it? To create multiple rows, what we do is we separate each of the square brackets inside the square bracket with a comma. Let me go again. To create multiple rows, we separate each of the square brackets inside the square bracket with a comma. So let me show us using this first. So when I create this list and I come inside it, I put a comma. I create another square bracket inside. So let's say 6, 7, 8, 9, 9, 10. I come again, I create another square bracket inside so that we are able to see the difference. I say 11, 12, 13, 14, 15. So when I run this, this is seen as just a whole list having multiple, what's it called? Multiple rows inside. Now, how am I able to see this very well? So when I convert this to an array of multiple dimension and I run it, oh, sorry, what does it do? It says, sorry, something is wrong somewhere. 1, 2, 3, 4, 5. Oh, I made a mistake. So I made a mistake here the other time. Instead of using comma, I used full stop. Now, the list did not see it as a problem because it felt like it is just normal. But in terms of an array, it discovered that there's a problem here, and as such, I had to like fix that. Now, we see here now that the way the array shows this is different from the way the list shows this. Now, when I want to see what is inside this place in terms of its shape, all I just have to do is I copy this and I say dot shape. So now this tells me that I have what, 3 rows and 5 columns. Is this correct? Yes, it is, because I have row 1, this is a row, this is row 2, this is row 3. Now this is column 1. Column 1 is 6, 1, 6, 11. Column 2 is 2, 7, 12. Column 3 is 3, 8, 13. This is column 4 and this is column 5. So this gives me the shape of the array that I have, which is array of 3 rows and 5 columns. So do you have any question before we move on? I take as silent as we have no question. So now, so we started NumPy array creation. So we've shown ourselves how we can create an array, right? So we've seen how we can create a one-dimension array, and we've seen how we can create a multi-dimensional array, because this is multi-dimension. This is two-dimension, rows and column. We can also create multiple dimension in terms of X, Y, and Z. Do we understand? So, but let's not just go there. So let's just continue with what we have. As we go on in terms of when we get to pandas, we'll see how we can undo X, Y, Z, and all of that dimensions. So, so the next thing we have here is indexing. Yes. Now, how we talked about indexing yesterday as location. So index is location, right? So when we say indexing, we are talking about locating a particular item. So when we say index this table, it means that you should put this table in such a way that you are able to easily locate certain things. So you can index on any column that you want. That makes it easier for us to locate whatever we want to locate. Now, how do we do indexing and how does indexing work? So we created this array the other time. So I want to call this single dimension array that we have. So I'll call this one array 1D. I'll put this, so I'll call this array 1D. And I'm going to call this array 2D. I want to put them in the same, let me put them in the same, and what's it called? The same this thing. So we have array 1D and array 2D. So now I can see array 1D. When I come, I say, give me array 1D. I see what array 1D is. Give me array 2D. I see that array 2D as this. So I can say, let me see the shape of array 1D. So I say array underscore 1D dot shape. Oops. So it gives me 5 rows. It sees this as rows with no column because of the shape that it is. Right now, in terms of array 2D shape, it sees it as an array of 3 rows and 5 columns. Now, how does indexing now work? Indexing literally means location, right? Like I said. So, and we told us that Python indexes start from 0. So when I say array 1D and I say square bracket 0, it means it should give me the item in the first location, right? So when I run this, it should give me 1 inside array 1D. Are we together? Now, how does it see location?
Hello.
Yes.
Please, can you take that again? That sounds confusing.
Okay, so I said in terms of indexing, Python starts its indexing from 0. So when it wants to locate an item, the first item is in location 0. Now, we've seen that this is our array, right? Now, the first item inside the array is 1, but it is sitting on location 0. Now, if I want to get 1, all I have to do is index. When I want to index, I use the square bracket to index and I put 0, the number inside it. So this tells, I'm telling Python here to give me the item that is in location 0. So when I run this, it gives me 1. If I want to get the item that is in location 1, I say 1. And when I run this, it will give me 2. Because this item is sitting on location 1. Don't forget, Python starts the location from what? From 0. So let's put that at the back of our mind when we are working. Now, this is how, so let me do this 0 so we are able to understand very well. Now, this is our first, so come here, first item in array 1D. Now, when I want to get the first item in array 2D, what is the first item? Now, the first item, I say ARR underscore 2D. And when I do square bracket 0, right, which is the rule for getting the first item, what does it give me? It gives me the first array. This is what it is going to give me. And I'm going to explain why. So it's going to give me this array 1 to 5 here. Oops. So we see here now it gives me array 1 to 5, which is the first item. So now in a single dimension, in a one-dimension array, the first item is the item inside it. Now in a multi-dimension array, the first item is the first what's it called? The first array inside the array. So a multi-dimension array is an array of array, an array inside an array. Do we get that, or I should come back again? So I said a one-dimension array is just a normal array, simple, straightforward array, no stress in terms of identifying the location of an item. But in a multi-dimension array, the array is an array inside an array. So you see, this is an array, one array, another array, another array, inside an array. So it means that if I want to get this one here inside this multi-dimension array, how do I do that? It means that I would do this twice. I would say the first item inside the array, which is this array. Now, if I want to now get the first item inside this array that I have, I would now say another square bracket and 0 again. So when I run this, this would now return 1 for me. Are we together? Are we together?
Yes.
All right. So now, in one-dimension array, if I want to get the fourth item, meaning the item sitting in the fourth location, right? I would say what? I would say array 1D square bracket 4, right? Meaning the one in location 4. So it's going to give me 5. So it means that when I look at it from here, 0, 1, 2, 3, 4. So number 5 is the person sitting on 4, right? This is it. Now, if I want to get the fourth item here, which is 4, right? Okay, 0, 1, 2, 3, 4. Sorry, the fourth item here, which is the one sitting on location 5 here. Location 4 here. How do I do that? I would say array 2D square bracket 0 square bracket 4. So when I do this now, it gives me 5. Now, if I want to locate number 14 here, how do I locate number 14? Now, don't forget that this is location 0, location 1, location 2, right? Inside location 0, there is now another location inside it. Location 0, location 1, location 1, location 2, location 3, location 4. So when we understand this, we are able to see, okay, where is 14 sitting? 14 is sitting on row 3, which is 0, 1, 2, right? Now, it is now sitting on which part in terms of the column? It is sitting on column 1, column 0, column 1, column 2, column 3. So here I would say array underscore 2d square bracket 2 square bracket 3. So when I run this, it gives me 14, which is what is here. Now, here now we are able to see and understand how Python handles multiple dimension in terms of arrays and in terms of the items location in terms of indexing, I mean. So now let's now also look at how it handles the last item. So let's say I don't know the last item. How do I pick the last item from an array? All I have to do is array 1d and I say -1. So -1, like we said, is what starts from the last item in the array that we have. So this gives me 5 because 5 is the last item here. Now when I do the same thing for array 2, what do I have? If I have -1, it's going to give me all of the array that is sitting on the last row because it's a multi-dimensional array. Now, if I now want to get the last item inside the last row, are we together? I will do what? I would say array 2d square bracket -1, another square bracket -1. So now this gives me what? The last item inside the last column inside the last row. Now if I want to get the first column inside.
Hello, sir.
Yeah, I'm with you.
Hello, sir.
I can hear you.
Hello, sir.
I can hear you.
Line 76 is not clear, sir.
Okay. You understand line 75, right?
I understand you, sir.
Okay, so now line 76, just like line 75, which is picking the last item in the array. Same way, if you are picking the last item in the multi-dimension array in the 2D, the last item is a row because it picks the row first. So now this gives the last row, which is this item. So when we come here into the last item here is all of this row first. Are we together? So it picks the last row first, and then the next thing it does is we can now pick the column in line 77. So but in line 76, what it does is it gives us all of the last item, which is the last row inside the multi-dimension array that we have. So moving forward, we are able to pick an item in terms of where it is located. Now let's now look at slicing and what does slicing does, or what is slicing for. So slicing basically is if you want to pick from certain parts of an array to a certain part. So it means I don't want to pick everything. I want to pick just one part of the array to another part. So let's say in array 1D, I want to pick the item sitting from the first location to the third location, from index 1 to index 3. Now, let us set something clearly. When you do this in Python, it is going to give you the item in index 1 and index 2 only. It is not going to return index 3 for you because it would stop at index 3 minus 1. So let me show us what I mean. So when I run this, it shows 2 and 3. Now let's go to our array and see what we have. In array 1D, what do we have? We have, this is in location 0, right? Location 1, location 2. Now it did not return location 3 for us because what? It stops at location 3 minus 1, which is location 2. That is how Python handles things. So if I want to pick location 3 with it, I would say what? I would say location 4. And then this would give me from location 1, location 2, and location 3. Now, same thing happens when we do it for two-dimension array. So when we do for two-dimension array, what do we have? If we do array underscore 2D, and I have in my row, I have give me from 1 to 4. Oops. Now, okay, so give me from 1 to 4, right? Now, we did not even have up to 4, but then it should work. Yeah, we did actually. So here we see that it returns row 2 and row 3 in terms of, row 1 in terms of the location and row 2. There is no row 3 because our array does not have what's it called, row 3 inside it. So that is why it stopped here. So if I do, so let me change this to 3. So now we see that it returns the same thing. Now this is in terms of the row. Now in terms of the colon, if I now want to pick colon, let's say 7, 8, and 12, 13, I would say what? I would say give me 1 and 3. So when I do this, no, this is not supposed to be. So I want to return 7, 8, 7 and 8, and 12 and 13 in terms of the row. So here now, I would say 2, because this is 0, 1. Yeah, this is supposed to be this and this. So when I run this, something is wrong. Oops, what did I do? Run this here. So here I would say 0, 1. So this is 1. And then I would say, so something is wrong. Oh. What is wrong? What is wrong? What is wrong? Oops. Okay, so I have this. Okay, so yeah, when I want to now pick the arrays inside of this array. So this is, for instance, I want to pick what's it called? Line. I have a multi-dimension again. Okay, so I have 2 give me this 0, 1. So this is I'm coming, please. Something is wrong again. Uh-huh. So it's not supposed to be. This thing is wrong. Oh God. Okay. Are we together? Hello, can you hear me?
Yes, sir.
Okay, yeah. So now, sorry. So so I was explaining how we were slicing, right? And we want to pick 7, 8, and 12, 12, 13, which are on column 1 and 2 for the 2 rows. So what we want is comma. So we'll separate them using a comma, and then we'll say column 1 and 3. So this way we are able to pick certain items inside the array itself. Sorry. So let me go again and explain how we are able to slice a multi-dimensional array, basically. So like I explained the other time, this is the first item, which is the row. So this is row 1, row 2, and row 3. Now, what we have here is, because it is a multi-dimension, automatically, how Python sees it as row, so it is row colon comma colon. So what we have here is row and colon. So if I want to pick an item in a specific colon now and a specific row, I can literally just say row comma colon. Unlike the other time when I was using indexing, I used like 0, 4 and all of that. I can also do that here and say 0 comma 4. So when I do that here, it comes and checks 1, 2, 3, 4, and row 0, it comes to column 4, and when I run this, it gives me 5. So these are ways to basically slice item inside a multi-dimension. And so when we are using, when we now want to pick multiple items inside the multi-dimension array itself, we can use this slicing feature, which is the colon between each of the numbers. So the first one, like I said, is the row, and the second one is the colon. So let me just put this here so we remember row and colon. So say structure or syntax.
Sir,
Yeah.
that 3, so I think it's supposed to be 2 because that 7 and 8 is in column 2, not 3.
Yes. Don't forget that I explained that when you are slicing, the last item that you want to pick, you make sure that the index is not the index you want to pick. So, for instance, I'm coming 1 minute, I will explain this again. So, for instance, we have, this is row 1 column 1 abi, I'm sorry, row 0 column 0, row 1 row
Yes.
0 column 1, row 0 column 2, row 0 column 3, row 0 column 4, right?
Yes.
Good. Now when we are picking, this is column what?
This one is column 3.
Column 3, but actually it is column 2 because Python starts from 0. Do we get? Now if we now want to stop on 3, we would not say 3 here, we would say 4. So let me show you what I mean. So we have array 2D, and I want to pick row 0, right, up
Yes.
to 3. So I would say, if I say 3 here, it gives me 0, 1, 2, and not 3, because it stops at what? It stops at the index here -1. Do we
Okay.
get it? So it's, when any index you put here, Python would automatically subtract 1 from it.
Okay.
So that's the way it is. Do we get it now?
Yes.
Yeah, all right. So now the next thing we want to do is the basic operations we can do on an array. Okay, I think we already talked about that we already talked about the operations that we can do on the array. Now, what are some of the other things we can do with NumPy before we go to Pandas? So the other things we can do with NumPy is looking at the functions inside. We can reshape an item. Yes, so we can reshape. So for instance, let me create an array. So let me call this what should I call this? Long array or something, or let me just call this guy array. It doesn't matter. So, and I say np.arrange, and I want it to give me 50 numbers starting from 1 to 50, right? So when I run this, it gives me 1 to 50, 1 to 49. Are we together? Do we know why it gave me 1 to 49 instead of 1 to 50?
Yes, because it understands 0. It starts from 0 instead of starting from 1. So it has to remove 1 from that 50 and give you 1 to 49.
No. Like I said, anytime you are stopping on any index in Python, Python would automatically subtract 1 from it. Let me show you what I mean. So when I look at the shape of this array now, there are going to be 49 rows in it, because instead of stopping on 50, it stops on 49, starting from 1. So when I need 1 to 50, I would say what? 1 comma 51. So when I run this now, it gives me 1 to 50. And when I run the shape, it gives me what? 50 rows and 0 column. So all of these are 50 rows and 0 column, right? Now, if I want to reshape this array that I have, that is of 50 rows and 0 columns to rows and column, how do I do that? I would use the function called reshape. And what does the reshape does? the reshape would change the structure from just rows to rows and column. So, but now when I say arr dot reshape, are we together? Arr dot reshape, what does it say? It says shape and order. Now, shape here, how do you state the shape? You give the shape in terms of rows and column. In terms of rows and column. Now, so let's do that. Now, how many rows do I want from 50 and how many columns? Now, there is a rule when you want to use the reshape function. The rule is that the multiplication of the rows and column that you have must be equal to the shape that you previously have. Let me say that again. The multiplication of the rows and column that you have, that you want to have, sorry, must be equal to the shape that you previously had. So I have 50 items here in 50 rows and column. If I want to reshape it, let's say in 5 rows, right? So I want to have 5 rows. How many columns would I have automatically? I would have 50. Oh, sorry, I have 10, because 5 times 10 is what? Is 50. Are we together? And so when I change this now, it changes the shape from a 1 dimension to a what? To a 2 dimension. Are we together?
Yes, sir.
So now we see how we can change the shape of something. So if I have an array in one shape, I can reshape it to another shape. Do we get it? But the rule is whatever shape that you have must be of the same size in terms of what is there with the previous array that you have. So if I come here and I say arr.size, you see it tells me what? 50, because there are 50 items inside it. Now, another thing that I can do is, we've used arrange the other time for NP and all of that with NumPy. Another thing we can create is we can have an array, we can have like an array of zeros. If you want to have an array of 0 numbers, so instead of saying 0, 0, 0, 0, so instead of me doing, let's say, np.array, and I say 0, 0, 0, 0, 0, and all of this, instead of me doing this, right, I can just do this by saying np.zeros. And when I do np.zeros, all I just have to state is how many zeros do I want? I want 10 zeros. So when I run this, it gives me what? 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do we get it? And the funny thing is, I can also reshape this. So I can just do dot reshape to, let's say, 5, 2. So when I do this, it changes the shape from what? To 5 rows. Don't forget rows and column. 5 rows, row 1, row 2, row 3, row 4, row 5, and 2 columns. Now, I can also create an array of ones. So if I want to have arrays that are just 1, 1, 1, 1, 1. So instead of me doing something like np.array 1, 1, 1, 1, 1, instead of me doing something like this, I can just say np.ones, and I would just state how many ones do I want. I want 20, and then it's going to give me 20 ones. Now, this comes very much handy when we are working with other arrays. Like we want to do a multiplication of arrays, for instance, or we want to perform an arithmetic operation with the arrays that we have. So this can come in handy. Now, can I create an array of what's it called, of other numbers? Yes, I can do that. But how do I do that? So for instance, if I want to create an array of 5, 5, 5, 5, 5, so let's say np.array, and I have 5, 5, 5, 5, 5, and all of this, right? I have this. I cannot have np.5s. This is not going to work if I do something like this. It's not going to work because NumPy does not have the attribute 5s. Now, how do I create an array of 5s like this? All I just have to do is I can just do np.1s, right? So when I do this, I can just say times 5. Are we together? So this literally gives me an array of 5s. Also, I can do it in another form by doing what? np.zeros plus what? Plus 5. This would add 5 to all of the zeros that I previously had. Now, these are some of the things. These are some of the things we can do with NumPy. So this is just what would undo NumPy. What did you say? Now the next thing we want to go to is Pandas. Are we there?
Yes, sir.
All right. So Pandas. Now we want to understand what exactly is Pandas. How do we work with series and data frame? What is series? What is data frame? And how do we read data from various data sources, Excel, CSV, and all of that. Now, Pandas is a Python library that is built on NumPy. So Pandas is an advance of NumPy. Are we there? And now Pandas itself, because it is an advance of NumPy, yes, works on rows and columns. So all of the operations that we do on arrays in NumPy, this time around, we are going to be doing them on rows and columns, Don't forget, we've shown ourselves how rows and columns are built from shapes and multi-dimension array. Now, Pandas is built on that multi-dimension array. Do we get it? Now, what is a series and what is a data frame? Now, a series in the simplest term is a column, one column in a table. Are we getting it? One column. So we have a table or we have an array, a multi-dimension array. One single column is a series. Now, a data frame itself is a table, a table that is formed in terms of more rows and columns that is created from a what's it called? That is created from a data set itself, because the data set that we have is the data that we are bringing in, that we are reading. So now this data frame is a combination of multiple series. When you have multiple series together, that's multiple columns together, you have what? A data frame. Are we together? Now, how do we then read data from various data sources? Now, the first thing that we'll do is
I'll go to my makeup place.
the first thing that we'll do.
Go to my makeup place.
Sorry, I can hear you. Are you talking to us?
On Wednesday.
Now, the first thing that you do to work with Pandas is you import Pandas. So we say import Pandas as PD. Now, I've explained why we have as and PD, just a variable name holding Pandas library itself. So when we run this is going to take some minutes, and then it would run. Don't bother yourself about what you have here. My Pandas is quite of old version, and it is telling me now that there is a newer version. So it says there is new version of 2.80, and I'm using version 2.78. I can update my Pandas, that's not a problem. So, but obviously it's still going to work. So this, we should note this so that whenever we have Pandas itself gets updated, we don't find ourselves having problems with this. It's not a big issue like that. So now, just the way we went to the extensions, the functions inside NumPy, there are also extensions and functions inside Pandas. So when we press dot and tab, it's going to show us all of the functions that we have inside of Pandas. So we see we have API, we have array, we have arrays, we have Boolean data type, we have categorical, we have concat, we have data frame, we have so there is pd.series. Yes, we have series also. We have a lot of them. We have to date time, to different data types and all of that. Now, all of this come in handy when we are working with rows and column. Now, I'm going to show us how we are able to use the multi-dimension array in NumPy that we create, and show us how it is visualized in Pandas. So let's start from using NumPy. So we say np dots. So let's create a list of numbers, right? And we want to use random numbers. I don't want us to use arrange this time around. We want to use random numbers from 0 to 50, anyone. So we say np dot random dot rand int, and then we say give me a random number from 0 to, let's say, 51, right? So when we do this, it gives me just one number. Now, if I want it that if I now want to create a list from this, how do I do this? All I would do is I would say np dot, so I want to create sorry, 1 minute. Okay, yes, if I want to create a list, so I would say the number of random numbers that I want 20. So now it creates an array of 20 random numbers for me. Do we understand? It creates the random numbers starting from 0 to 51, and it gives me how many of them? 20 of them. Now this is an array, right? So I want to call this random array. Right? So I want to create, so when I run this now, so I have this. Now this is an array that has been created, and it is a single dimension array, right? Now if I want to make it a multi-dimensional array, how do I do that? All I would do is what? I'll say random array dot reshape, right? And then I'll state the number of rows and columns that I want. So let me say give me 4 rows and 5 columns. Don't forget that the multiplication of our rows and columns must be equal to the size of the array we want to reshape. So when I do this now and I run this, so it shapes the array for me, right? Now, if I want to keep this array stored inside this variable name that I created before, I would just say random array equals to random array dot reshape. So it means that the array that I have created before, now I have reshaped it here, and so I can just say random array. Are we together? Everything we are doing here so far, we are still using NumPy, right? Now, how do we now change this multi-dimensional array that we have here into a Pandas data frame? all we would do is we would say pd dot data frame, open bracket. And if we look at it, what does it say? It says that what? Data. So we have to state our data. What is the data we want to use? Random array. So when we do this now, and we put it inside here and we run it, we'll see now that the numbers that we have here in rows and column are now visualized in such a way that they are coming in rows and column in the form of a table. Are we getting it? Are we together?
Yes, sir.
Any question? Now, let's now, like I said the other time, I said that Pandas is what? Sorry, I said a data frame. A data frame is a collection of what? Is a collection or a group of series. All right. It's a collection or a group of series. So, a group of series. Now, this means that each of these, and I said a series is what? And I said a series is a column, right? So it means that this part, this 0, column 0 is a series, column 1 is a series, column 2 is a series, column 3 is a series, column 4 is a series, right? Now, let's now show ourselves how the series is visualized. So if I say pd.series, are we together? And I say random array. What does it say? It says that what? Data must be one-dimensional, but it got what? It got multi-dimensional, n-dimensional array. Now, for us to get a one-dimensional array, what do? We would call the just one column. And now we see now that this gives us a series. Are we together? Please, if you are not getting it, let me know. Now we see now that a series is what? Is one-dimensional. It is just one column. If it is more than one column, it will return an error. Now, this is a series. Now, if we come here again and we put this again and say 1, it will return column 1. Aha, sorry. I made a mistake the other time, sir. It returned row 1 for us. It returned row 1 for us, right? Because this is row in terms of how it is visualized. Now, if we come here and I put a comma before the row, it returns an error. So how do we return a column in a data frame now in Pandas? To do that, we would put this name that we have here. Please mute yourself, the person that has noise coming from this place. So we would have this in a quote. So when we do this and we run this, so it says now there is an error. What is the error? It says integer slice FPC. All of these boolean are valid indices. So this is a valid index that we can have, but it is only returning rows for us. But we want it to return column. How do we do that? Now, for it to return column, so now this return series returns row. Now, if we want it to return column, how do we do that? So we'd say, okay, there is a function called iloc. There's a function called what? iloc. Lock is not here. Okay.
Uh,
So it says this does not have. Okay, so there's a function called iLog basically, and that function is what would use to pick the column. But now this is not on the series. So when we get there, I will show us how we use that. But how do we do it such that we are able to rename our columns in a table? Now, this data frame that I've created here, I want to call it DF. I want to call this data frame that we've created, I want to call it DF. So when I say DF now, it stores this data frame. So when I call DF, I have this data frame, and I have, so when I do DF dot iLock, are we together? So when I call DF dot iLock and I say 0, it returns this column, this row for me. But when I do DF and I do 0, it returns the column for me. Do we understand? Or should I come again?
Come again, sir.
come again, sir.
Now, the other time I told us that in a series, whenever we call the location 0, it picks the index, which is this index, right? This index 0. It is not this column. It is picking the row as the index. And as such, when I call random 0 in terms of a series, it gives me all of the value in row 0. Now, but when I want the data to be returned in form of column 0 and not row 0, how do I do that? What I have to do is I have to use the function. So there's a function called iLock in data frame, Pandas data frame. And what does iLock does? iLock returns rows, while the header itself returns columns. So now, this Pandas data frame, I've called it df. And I said df should give me 0, the location 0. Now, data frame in its own view sees a column 0 and not index 0. But if I want to return index 0 in data frame, I would use df.ilock, which would return the rows for me in data frame. So here I have data frame returns row. I use df.ilock. But when I want to pick the column for data frame, I just use the header name. I use what? The header name returns column. Now, how am I sure that I use the header name? So this is 0 here. Let me make this 0 in terms of a string. So I put this in quotes and I run it. What does it say? It says it does not identify 0, because the 0 here is a what? Is an integer and not a string. So we are able to see how we create a data frame from a NumPy array. Are we together? Now we've created a data frame here from what? From a NumPy array. Please give me 1 minute. I'll be back. All right, are we together? Are we together? Now, the next thing on our list to do is reading data from various data sources. Now, we've seen how we can create a data frame from and a series from a NumPy array. Now, we now want to use data. We don't want to create random numbers. We don't want to use random numbers here, like we have it here. So we want to have our own data. So let me just call this reading data from various data sources. So I've sent us I sent us a CSV file, right, which contains some data. So I sent us this sales data. It's a CSV file, and we'll be using it. This will be what we'll be working with today. So how do we read files from various data from various data sources? So we use what we have, PD. Don't forget our PD is Pandas. I will say dots. So PD has something called read. So I want to show us some of the things we have under read. So we have read clipboard. So Pandas is so Python is so powerful in terms of using Pandas that I can literally go and copy a table from somewhere. And when I say read clipboard, it understands that what I've copied, it should read it as a table. Same thing for CSV. So if I want to read a CSV file, I can use read CSV. If I want to read an Excel file, I would use read Excel. If I have a data from a website, I want to convert a table that is sitting on the website. I want to convert it to a data frame on Pandas. I can use HTML. So let me just try to, I don't know, words, athletic, something. I think I did something on athletic ranking. Yeah, I did something around this sometimes ago. So if I want to read like a table, this table, for instance, if I have this medal table that is on a website, good, I have this table on a website. If I want to read it in my Pandas, I can use read HTML, right? So if I have an SQL data, so if the data is sitting in an SQL database, I can connect my Pandas. I can connect Python using Pandas to SQL database. I can also connect it to an SQL table. I can connect it to various data sources that we have here. So I'm just going to play around with some of them so we see. So if I do pd.read HTML, for instance, all I just have to do is the HTML, the website link where the table is sitting. All I just have to do is copy the link and come to Python and put the link here. I have to put the link in quotes. Don't forget, I have to put the link in quotes. And so when I run it, it's going to take a while connecting to the website, and automatically it's going to give me the data that I have inside the data, like the website itself. So here we see that the data itself is not coming in form of a data frame yet. And why is it not coming in form of a data frame? It's not coming in form of a data frame because there is only one table here inside the website. So I can do something. Now we'll see that this thing is coming in form of an array, right? Because it has this square bracket in it. So for me to pick this data itself inside this array, all I will just do is I'll just call the location. I'll put a square bracket in front and 0 because it is in location 0. That's the first table. So when I do this now and I run it, now my data comes in as a table, a data frame. So this now, when we look at it, looks like what we have inside this place. Am I correct? So we see we have here, this is gold, this is silver, this is bronze. but what is coming here is showing unnamed 2, unnamed 3, unnamed 4. Now, this is like an unclaimed, a data that requires me to change the column names. But we see that we have exactly the same data that is on this website. You see on this website, the website that I actually did not know who created it. So, well, I can guess who created it. Like, it was created by World Athletic Forum. But here, I was not the one that created it. I was not the developer. I don't know anything. All I just use is the website link, and I can use it to create a table. This is a data frame, and I can save it. But I don't want to create a variable name to save this, so I'll just leave this here for us. So let's now see how we can read a CSV file or an Excel file and how to work around it. So to read a CSV file, all we just have to do is say what pd.read_CSV, right? And then we open a bracket, and inside the bracket we would state the name of our CSV file. What is the name of our CSV file? The name of our CSV file is salesdata.csv, right? Salesdata.csv. So I come here, I say sales data. You must be careful of the name, the way the file is saved. So there is no permission to do mistake, or you cannot write the wrong file name. So we say salesdata.csv. So we write .csv, and then we run it. Now, what does it say? It says UTF-8. Codex can't decode bytes, this and all of that. Now, this is a problem. Now, this is a Unix decode error. And this can happen because the file that we want to read from, it has a different Unicode code itself. It has a different Unicode. And I deliberately say we should use this file because once we are learning and we make these mistakes, we see these errors, we get familiar with them, and we know that, oh, I've seen this error before. This is how I can fix it and all of that. Now, to fix this, what we need to do is we need to go inside our Python, the read CSV settings itself, and then from here we would see something called encoding error. So it is set to be strict. Now it means that if the encoding function is not equal to what we want, it should not work. So how do we fix this? Now, to fix this, we can do this two ways. You can just copy this error message that you have and then search online. Are we together? And then you see you have a Unicode error can't read. So you have something like this. So you can just literally check it and see why it cannot read. And then what do you have? So you see here it says the code that we have is pd.read file name.csv, and then it cannot read. And all you have to do is just come here and state the encoding to what? To Latin 1. Now, remember the other time I showed us what inside this pd.read attribute itself, it talks about the encoding, where's this guy? Encoding error, yes, which is strict. Now, this is because the encoding that has been used or that it uses has to align with what is set in PD, like in read CSV itself. So all we just have to do is use the extension encoding equals to Latin 1. So when we run this now, it reads the CSV file that we have. Now, this tells us that the file that we have has a different encoding structure, compared to what pd.read expects it to have. So when we have issues like this, all we just have to do is copy the error message that you have, especially when you are reading files like this, and then try to get the encoding structure that it comes with. Now, from here, now we'll see that we've read the data that we have. Now, this is how to read a CSV file. So reading a CSV file. Are we together? Is there any question? Is there any question before we move on? All right. So since there is no question, the next thing we want to do is we'll see here that at the bottom, our data has 2,823 rows and 25 columns, which is pretty much in terms of the number of rows, in terms of the number of columns. In terms of number of rows, it's very, very small. So how do we, what's the next thing for us to do according to our syllabus? So the next thing for us to do is data cleaning and data preparation. Now, but before we go to data cleaning, one of the first things we need to do is we need to name our file. So we want to call this file, let's call it sales data equals to this sales data. So we have this now, right? So we've stored our CSV file inside a variable name called sales data. And we can then call sales data anytime. Now, the first thing we want to always do is it is not always good to view what we have all together like this. Why? Because imagine you have a data that is about 50 million rows, and then you have, like, let's say 20 columns or 25 columns or 50 columns, depending, and you are calling the data itself all like this. It is going to load all of the rows. It's just like saying select star in SQL. I hope you can hear me clearly. If I'm not talking to myself.
We can hear you.
Okay, all right, yeah. So when you call the variable name here in Python, it is like saying you are doing select star in SQL. So it is not always encouraging whenever you read a file or load in a file like this and you want to bring it in. So all you should do is, it is always advisable to do the variable name that you have for the table that you've created and do .ed. Now, what does .ed do? .ed by default returns the first 5 rows. Returns the first 5 rows in the data. So you have 5 rows and all of the columns. But this is not all of the data that you have inside it. But this helps you, it gives you an insight to the type of data you are working with. And it gives you an understanding of what is inside each of the columns without you running everything. So the equivalent of doing sales data.ed here is like saying you do select star .table limit 5, or you put a limit in SQL. So we are able to, the reason why I'm giving reference to SQL is so that we are able to understand the comparison between Python and SQL and how they handle data itself. Because now we are beginning to handle data directly, just the way we could have it using any other tool. Now, the next thing we want to do before we begin data cleaning at all, because data cleaning is the next thing we are supposed to do, right? Now, before we begin data cleaning at all, the other things we want to do is we want to know about the data that we have. We want to know about what the data that we have. Now, how do we do that? We use our variable that we've created, sales data, right? And we say .info. What? .info. And when you do this, it's going to list out all of, okay, I was supposed to actually, okay, before I do .info, I'm supposed to have .shape. Oh, sorry. So you're supposed to have .shape. So .shape here now tells us the number of rows and the number of columns that we have. Are we getting it now? So we have 285 and 2,823 rows and 25 columns, just like we saw the other time. But now we are able to see it better now. So .shape tells us the structure. Now, what other thing can we have under sales data? Can we have something like .size? Now, .size. What is .size? .size basically means the number of items inside it. So it is basically a multiplication of the rows and the column. That is size. The multiplication of rows and column. So if you multiply 2, so let's just do something. I don't want to stress myself carrying calculator. If I do this, I should have 70,575, which is the size that we have here. Are we together? So we see that .size is a multiplication of the rows and the column. Now, the next thing we want to do is we want to see and understand the type of data that is inside each of the columns, right? Each of the columns, what kind of data is inside it? Now, would say what? Sales data dot info. Sales data dot info. Now, sales data dot info will now start telling us what is inside it. So the first thing it tells us is what? It tells us the number of entries that we have, which is the number of rows that we have. That's 2823. We see that here. We see the number. So now we see the indexes. So in index is what? It starts from index 0 to index 2822. Now we understand all of the things we've been explaining before of how Python handles indexing in lists. So which is also the same thing in form of array, and which is also the same structure. It handles it in a data frame. Now it also tells us here that we have what? 25 columns, total column 25. Now each of the columns now that we have, it now begins to break it down and tell us what is inside it. Now we have 2,825 rows, right? Now each of these rows by default, they must not have an empty data. So it means that if you have order number cannot be empty. If you have quantity ordered, it should not be empty. If you have price each, it should not be empty. So there must not be an empty record in each of the columns that we have by default. So when we look at it, we have here 2823, 2823, and it tells us the type of data type that is inside it. So we see here number, we see here number, we see here decimal, right? So we see here we have number, integer, price each, float is decimal. Now order line number, integer, sales, float. Now when we come here, what exactly is sales? Sales could probably be the price of the item sold. So this could be 30 multiplied by 95 times 95.70. So this is sales. So it's a multiplication of an integer and float. Now the next thing we have is order date. Now order date is an object. Meanwhile, our order date is supposed to be a date. It's supposed to be a date because it is a data type. Date is a data type in Python. So status is an object. Quantity, quarter ID, month ID. These are also some of the things that we need to note. So year is supposed to come in as a year.
A letter.
Yeah. Yeah.
Under that data type, what is the meaning of that 64 that is after that float?
Okay, so the 64 that is after it is showing us the size of the integer itself. So there are two sizes. There is integer 32 and integer 64. Same thing for float, size 32 and 64. Each of the sizes have number of characters that they can hold. I don't know if when you were treating SQL, when you were trying to import data, like bringing flat files and all of that, you would see that you create certain size for your variable names. I'm sorry, for your data type. So if you have varchar, for instance, you have varchar 50, varchar 25, varchar 32, different sizes, just so that you create the size that should be inside that item, that should be inside that column, I mean. So that way you don't have data that is coming in that is lesser, and also you don't have data that is coming in that weighs beyond what is supposed to be inside. Sorry, that what's supposed to be inside the what's it called? The type of data that is supposed to be held in that column. And please give me 1 minute, please. I'm coming. $4.50. That's different from Akin. So yeah, I'm back. So now we see that some of our data did not come in the way we expect them to come in. For instance, we expected our sales date, our order date to come in as a date time. Because when we look at it here, it has date and it also had time with it. So this is something that we want to fix, we want to clean. So this is where data cleaning comes in. So this is where data cleaning comes in. And please, by 4:05, we'll go for a break so that we'll rest a bit, and then we can come back after that for like our last part of the whole class. So so we see now here that we see that here that we have certain data coming in and the data type is not correct. So let's also see, when we go through it, we'll see that also some data came in as null, like empty. So for instance, we are supposed to have 2823 records, but in address line 2, we see that we have 302 records. So it means a lot of the customers do not have any record for address line 2. Also, we see that some of them do not have states. Some of them do not have postal code. Some of them do not have territories. And yes, so all of these empty data that we have, we will have to clean them so that we have our data prepared before we even start performing any analysis at all. So the next thing we'll be doing when we come back from our break is data cleaning and all of this. So we'll be handling data cleaning, handling missing data, all of the missing data that we have, removing duplicates where we have duplicates, the data type conversion, how to change data type like that of the date that we have, and then we'll be doing some basic data exploration. We just want to see what is inside this, how to just basic exploration. This will be what we'll be doing when we get back. And also we'll then go into data selection, data filtering, Boolean indexing, and filtering, so that we are able to see how we do that. So we'll be going for a break now. So when we are back, we would continue from here. Do we have anyone with questions before we go for break? Any question? If there is no question, we would pause here and go for a break. So by 4:20, we'll be back, and then we'll continue and we'll complete the section by then.
Now having producing 620,000.
Yeah, hello.
All single line string as advanced carbon capture technology.
We're here.
Yeah. All right, so let's continue. Okay, so we have our data, and we see that we have certain columns that are empty. Now, how do we undo missing data? This is one question that is very rampant. How do we undo missing data? Now, there are different strategies to handling missing data. There is no one way to handle missing data. The first way is that we want to look at the column that we have missing data. What exactly is there? So for instance, we have a lot of missing data in address line 2. Now, in situation like this where a lot of missing data are, okay, so let me first tell us the theoretical part of, or the theoretical way of handling missing data. First is you replace the missing data with a value. So if, for instance, we are working with, let's say, okay, quantity ordered, and the quantity ordered is 0. In situation like that, where you know that, okay, no, I cannot use quantity order. Quantity order is a primary colon here. So let me use something like, let's say, months, or yes, okay, good. I can even use it. So let's use ordered number, for instance. Ordered number, for instance, is empty. Meaning in a sales data where you have order number to be empty, that means there is no order in that particular thing. So every record that you have under that order number might not be valid, because probably the records came from one something and there was no other number to it. So in situation like that, you might have to replace it with a particular number, let's say 99999, and then you report and say that all of the records or all of the IDs that have 99999 did not have an order number primarily from the source. That way, you've replaced the null value there with a value. Now, another way to handle missing value is to run the mean, the average of all of what is inside the column, and then use it as the record for the missing value. Things like that can occur in situations where you are working with, let's say, age, for instance, and then certain maybe students have missing age. So instead of removing those students or their records, you can literally replace their record with the average age of the group. Things like that can work. Another way is you remove totally the record, either the row or the column, depending on what you are working with, either the row or the column. Now, how do you remove the column? So for instance, we have something like address 2. In address 2, for instance, we see that there are a lot of missing records in this column. So by default, we can remove it. There is a rule that if the percentage of missing records is more than, I think 70 or 80% of that column, you can remove it. But in real data, when you are working, you have to be very, very careful. So you have to ask questions. these records that we have here, are they needed records, or we really don't need them? But most times when you're performing analysis, or when you are when you are performing analysis and you are doing data preparation, you most times do not need address line 2 in most scenario. So in situations like this, we would have to remove them. So address line 2 colon would have to be dropped. Now, in situations where you have territory, what do you do? Also, another way to handle missing data is to replace the value with what it was at the top. So for instance, let's say I have, let me go to territory. Okay, aha. So territory, for instance, for USA is none. It is empty here, right? Same thing here, it is empty. Same thing here, it is empty. So when we look at things like this, you need to, first of all, go into the data and understand what are those territories what are those records that have missing data. And as such, once you understand it, that would also guide you in replacing them. So when we get to searching what is going on in territory, we might have to see if all of the territories that are missing are from USA. If all of the territories that are missing are from USA, then we can replace it with something based on understanding that we have. So when we get there, we'll see how we handle all of these missing records and that. So let's start. So the first one we want to undo, the first missing column that we have is address line 2, right? So to handle this, we would say sales data, square brackets, quote address line 2. When we do this, we'll see that there are a lot of none. So what we do is we say, so let's remove this first and say sales data dot drop. Are we together? Dot drop. Now, when we come to dot drop, what do we have? We have label, we have X, we have axis, we have index, we have columns, we have level, we have in place, we have errors. Now, just to be straight with us, what does axis mean? Axis 0 is row, axis 1 is column. So it means if you want to remove all of the records in a column, you would remove it based on the axis 0. Now, sometimes you might want to remove based on row, depending. So it means you want to remove everything in that row, just one row. So this is where axis comes into play. Also, when you want to have a certain index number, so maybe you know that line 0, you want to remove all of the first records. All you just have to do is you have to state the index. Now, in terms of column, when you want to remove a particular column, you use the undo columns and then you state the columns inside it. Now, how does this work? When we go in between, we'll see example. So example we have here, drop. So we have a data frame that has column A, B, C, and D. And then you see here it says that what? We want to drop columns. Which columns do you want to drop? B and C, right? And what do we want to do? We want to drop them on axis 1, meaning you want to drop all of that column. Do we get it? Another way you can do that is to just say drop and you state columns. After stating columns, you put the column names that you want to drop and then you don't put the axis. It's going to remove all of that columns also. So I prefer using this method of doing drop and you state the columns. This way, it helps whoever is reading your code, because one of the attributes or one of the good attributes or characteristics of a good data analyst is, or a good data analyst or a good programmer generally, is that your code is readable by someone else. That's one of the good characteristics of someone that is very good, because if you are not around, someone else should be able to read your code and understand that, okay, this is what is going on and this is how to solve the problem. So we'll copy this and then come here and say open bracket, and then we state our, so sorry. So we state our columns. Now the column we want to remove is, address line 2. So this is the only column we want to remove. So we want to drop. So we use the name drop and you put it in a square bracket. So when we run this now, the next thing we want to do is we want to make sure that it is completely removed from our table. Now, how do we make sure that it is completely removed from our table? We use the code, or we use the argument called in place. We use the argument called in place. So when we use in place, by default, in place is false, meaning it does not do anything. But when we comma, we write in place and we say in place equals to true, this means that what we have done should be static. It should be what is there. Now let's now do something. Let's now do sales data and do edge. So now when we do this, we will be able to see what is exactly going on from what we've written. So when we run this now, oops, you can go. Okay, so it says address line 2 is not found. Okay, so sorry, something went wrong the other time. So okay, let's go again. Now when I do sales.drop address line 2 now, and I do in place, now when I run this, we will see now that the number of columns that we have is now what? Is now 24. Why? It has removed address line 2 from our data. Are we together? So we've removed that column completely. Now the next thing is we also have null value on state. Now let's now check what are the places where the null value on the state does not, we don't have values for it. Okay, we'll see here that we do not have value for certain states, but there is something interesting. There are a lot of data on the state column, right? This is almost like more than 40% of the data in that column. So it means that there are data there. So let's check. We have to investigate. Let's check what exactly is going on inside this state record. So one thing we will do is we want to look at all of the values that are inside the state column itself. How do we get all of the values that are inside the state column? We would say sales data, and we put state, and then we say dot unique. We say what? Dot unique. So when we run this, it gives us a list of this, but this is not what we want. So we have to use this the bracket here. So now this writes out all of the unique states that we have. So we have NY, we have none, we have CA, we have Victoria, we have NJ, we have CT, we have MA. All of these states that we have here, let me check the numbers. So for us to see the number of states that we have, the unique, we say N unique. We have just 16 states in all of these records. Now, in my opinion, because these states, some of them or most of them, we do not know the full name of these states, we might have to drop this colon. And for us to now perform the analysis that we want to perform, our analysis will now be on the city in terms of when we want to perform location. Do we get it? So we are able to look at which city has the number of sales, which city has generated the most amount, and all of that. So we can use the city record because it is complete. It does not have any null value. And then some states, we do not know them. So to do this now, it means that we would come back here and copy this our line of code again. And actually, instead of copying it, we can just come here and just remove it. So we remove state also. Are we together? Any question? Now, the other columns that are empty is we have postal code. So let's also investigate postal code and see what exactly is going on with postal code. So we have postal code. So here we have just numbers. We have just numbers in postal code. And one of the things that we really do not also need, especially when we are performing analysis, is So one of the things that we also want to take note of, especially when we are performing analysis, is situations where the columns that we need or the columns that we have in our data are not useful. That's another thing that we also need to take note of. Things like postal code here also might not be useful, especially when you are performing analysis, because you are not using it. Basically, you are not using it, and each of these postal codes are related to a particular location. So these are always useful in terms of address, city, states, postal code, countries. All of these columns are usually useful when you are performing location analysis for a particular analysis that you are doing. So we do not also need postal code in this situation. So what we'll do is we would add it to the list of columns that we want to remove. If we are confused, please let me know so that we are on the same page. So the next thing we also want to do is we want to check territories. Now we want to see which territories are missing. Now, one of the things we want to do along with territory, because territory relies on country, and so we want to see all of the territories that are empty, right? So let's say we have okay, we have, oops, I'm not supposed to remove this. So let me come here. I say sales data, and we want to have territory. And we want to see where territory is null, right? So we run this, for instance, we see what we have. We can check the unique values that we have first. So we see all of the territories we have. So we have territory called Japan, we have territory called APAC, we have territory called EMEA. So if we want to see the territories that are empty, how do we look at it? Now, what we have to do is we use something called isNull. Now, isNull basically returns all of the columns. Now, you see we have this is true, this is true, this is true, this is false. So now, this tells us that we have a Boolean result of the territories that are null. Now, how do we now see the actual data for this? All we have to do is we just call sales data, we put it in square brackets, and we also put this in square brackets. So when we run this now, all of the records that we have here, all of these records, 1074, they all have null territories. Are we together? They all have null territories. Now, all of these null territories, so let me create a variable called null territory. So we are able to use it very well. So we have this called null territory. Right? So this is all of the records that have null territories. Now we want to see what are the countries inside these records that have no territory. This way, we are able to look at what we should do. Either we would perform a replacement on the null values, or we would drop it. Do we get it? Now, how then do we see all of the states that are here, all of the countries that are inside these no territory records that we have? So all we just have to do is we say country now. So we want to look at country. And then we want to, look at the countries and we want to say .unique. So it should give us all of the unique countries that we have. So there are two countries inside this record that we have, which is USA and Canada. Now, for some of us that might be familiar with geography, would see that these two countries are actually in North America. So it means that the territory for these records is North America. Yes, which is also, I think they use NAM for them also. So because the territories that we have are in abbreviation. So we can use North America for them, or we can just go online and search what territory is USA and Canada. So this should give us something. What's one of these ones? Basically, they are inside North America. I don't know what this loader is giving me. Anyway, so USA and let me just use. So they belong to North America, and that's the territory they use for them in terms of grouping. So it means that our territories that are empty would have to replace those ones by what's it called? By NA, or we could just use NAM, which is North America. Now, I think we've gone through all of the, yes, so I'm going to run this again. Okay, so now it means that these are the columns that we want to drop. We do not need them. Also, yeah, another thing is we could also look into columns that are also inside the table that we might not need. One of them, so this is, let me first put this, handling missing data. So here we are, it's not handling, removing columns with missing data. So here we are removing columns with missing data, which is what we are doing here. Now the next thing we want to do is, so we would run this, and then I'll come and explain the next thing that we've talked about. So we've run this and we have 22 columns now. Now the next thing we want to do is we want to also undo these territories that are null. And in this case, what we are doing is we are replacing all of the null values in territory with North America, which we are using NAM for. So we say replace null values in territory with NAM. So how do we do that? So we do that by saying sales data. We bring in our territory, and then we use something called fill NA. Are we together? We use something called fill NA. Fill NA means fill null values. And what do? We want to fill NA with what? With NAM, which means North America. So when we do this now and okay, so I forgot to also mention, so we can also look into what exactly does fill NA takes. and how it works also. So fill NA is fill null value, like I mentioned, and we can state the method we want to use, depending either we want to fill NA in backward style, in upward style, like you start backward propagation and all of that. Then we also want to see in place, and we can also set limits in terms of the number of consecutive null values that it should fill. And what else again do we have? Yes, so we can also have a downcast in terms of how we want to fill the null values. But for us, what is important is the value that we want to put in, and also making sure that the change that we've done here is in place, is static. So we say in place equals to true. Oops. In place equals to true. And we also want to see what is done so far. So we say sales data dot head. So when we run this now, we can see inside that our null values that were for USA before have now changed to NAM. You can see here that it has also changed to NAM. It has also changed to NAM. Now, the other thing we want to now do is we want to now see all of the changes we've done so far. Let's now see the information that we have inside. So we say sales data.info again. Now, this time around, we would see that we do not have any null value. Are we together? We do not have any column that has null value. All of the columns that we have, they all have the same number of values, which means every record that we have, every record is the same, is filled, and we do not have any missing record also. That's another thing we should also take note, especially when we are handling missing records. We do not have any missing record. Our record from the beginning is 2008-28, and it still remained like that. Now, the next thing is we want to remove duplicates. But before we go to removing duplicates, I also want to mention that it is important for us to remove columns that we do not need. You know, we talked about how all of these records that we are doing, all of these analysis operations that we are processing that we are doing, what's it called? They consume space, right? They consume space in our system. And exactly, even when you are working on big data and all of that, all of the records that you have consume space. So you have to be very, very careful in terms of which records do I need, which records do I take. The columns that you do not need, you drop them off. So that, but also you have to be very careful in dropping off columns so that you don't just drop any random column. But before we get there, before we get to dropping off all of these columns and all of that, we would also I think it is important for us to look at removing duplicates and all of those things. So now, how do we remove duplicates? Would say sales data dot. Now, dot, if we come here, if we press the tab button and we type duplicate, you see here it says what? Drop duplicate, meaning it should remove all the duplicates that we have. But before we drop duplicates, we should see if there are actually duplicates. So we should check duplicated first. And then we'll see here that it says null, null, false, 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 false. But all of this false, we need to confirm because we are not seeing everything. So for us to confirm, we say sales data, and we put this inside a square bracket and see. Now we'll see here that there is no record that is duplicated. We see that there is no record that is duplicated. So automatically, this tells us that we do not have any duplicates. Do we get? We do not have any duplicates. So here we say what we check for duplicated records. Now, this is very important because sometimes there could be duplicated records depending on the type of data you are working with and depending on what you are doing. or even the records you want to check. Sometimes you do not want duplicated records on certain columns and not even all of your columns. So this is something that is important for us to take note of. So now, but if we have duplicated records, how do you remove them? To remove duplicated records, so let me just put it, to remove duplicate records or duplicated records from a data frame, you do what? You say sales data dot drop, sorry, oops, from dot drop what? Duplicate, and then it will automatically run and remove duplicates. But since we do not have this, so all our records are intact. Now the next thing we have under our tags is data type conversion. Yes, so we talked about the data types that we're supposed to convert, especially date time, like we have here. And which other one did we notice the other time? We don't know what MSRP means, except we check what MSRP mean. So if we want to check what MSRP mean and what is inside, okay, okay, so let's check what is inside MSRP. So we say sales data MSRP. So we see that it is just numbers that are inside. So we don't need to change that. It says integers. So products code, okay, product code is an object. It's not something we need to change. Anyways, the only thing we see that we need to change here is our order dates, right? So let's go into order date and see what is going on before we begin to perform our data type conversion. Okay, so in our order dates, we see something. We have dates, which is month, date, year, and we have time, right? So how do we change this data type from object to a data type called date time? So we want to convert. So we want to convert order dates data type from object to date time. Now, to do this, all we have to do is we would say pd dot. Now, when we look at pd dot and we come scroll down, we have something called to date time. We have something called what? To date time. So it means that it should convert this record to date time. So we would click this and we would open our bracket. So when we open bracket, we would see here that it says that what? It takes an argument, a date time or a convertible date basically, and then we know we can check if the day is the first or the year is the first. Now, in Nigeria, I'm going to say this, in Nigeria, we have this misconception on dates, and we always state our date as day, month, year, you get. But actually, the correct date format is supposed to be year, month, day. That is actually the way it's supposed to be. But there are also different date formats according to different countries. That's something we need to take note of. And so in some countries, we have it as month, year, month, day, and year. So we have the month first, which is what we have in this record, the date and the year. So depending on the way your data comes in, you can literally tell Python that in my data, I have the day first. So take note of the first record you see as the date and not as the day and not the month. And also you can literally tell Python that, oh, in my data, I have the year first, so that it takes note of that also. Also, we can state the format that we want our record to come in terms of being a string or all of that, depending on what we want. But because of the type of date that we format that we have here, we really do not have any change to make here. So we just have to state the colon, and then we would also, yes. Okay, yes. So we would also do this.
Hello, sir. Let's
Yes.
try to change the date to United Kingdom format so that we will know how to change date.
Okay, so it's this, that is what is going to change it to actually, and the format is, I think the United Kingdom format is month, day, year, right? Oh, it is day, month, year, which is what most of us use. But we cannot use that except we change the structure here in this string format that we have, this format that we have here, and then we have to literally state the format we want to use here, which is using percentage, day, month, year. Are we together? But we have to be very, very careful with this. But it's something that we can set if we want. So if we want to use that format, we can set it here by just using this. So we have percentage D, small letter D for date, percentage M for month, and percentage year, which is different from what is coming in. But are we saying we should use that, right?
Yes, let's use it so that we will know how to use it later.
Okay, so we can just state here format equals to this percent. So we have the formats we are using, we've decided to use this day, month, and year. But okay, before we even do that, let's do something, which is would create the date time first, see the way it looks, and then we'll create the format on it. So let's just see what would happen if we do this. So when we do this now, we would see now that it creates months, year, month, and day. This is the way it takes this thing. But now if we change our format by putting format, we would see the difference. But let me just put this on another line so that we are able to see the difference now. So when we run this now, okay, it says there's an error. The error is date time doesn't match the format. Okay, so you might use day first along with this. So it's saying that the format that we have is different from what is coming in inside the data. So, and it's telling us that we should have the day first, what's it called, argument. So if we come inside there and we say day first equals to, now we would have to change this to 2 because we want it to be true. Okay, there's still a problem. It says same thing. Why are you not disturbing my life? You did this false before. Okay, so month doesn't match with this at position 0. You might want to try pass format. Your string is consistent. Format equals to. Okay, so we might have to learn which format to use. So let's check date format and we say, yep. Okay, yes, the same thing now. This is what we put there. It's the same thing. Okay, so okay, so it had another problem. Oops. We have a problem again. Another problem back to back. Okay, so the date format that we want to create is not possible. And that's why I said the other time that when we are using Python, the date format has to be changed to the structure that it uses, like the one Python uses. Reason is because it would help us to extract each of the dates, each of the part of the dates that we have, the date part that we have easily. So for instance, when you want to extract year from the data, it is easier for you to extract it from the dates if it is following that structure. So that was why I said earlier on that the correct format of our dates should actually be year, month, and date. Now, if we now have a data, now to go in line with what you've mentioned, if we now have a data that is following the UK date format, which is date, month, year, what we would have to do is that when we want to convert that data, that date column to date time, we would have to state it that the date first, the day first is true, so that Python understands that, okay, this data that I have is following the day first, and it is following this structure. And once it sees that, it will automatically change the date format to what we have here. Do we get it now? So we cannot basically force Python to go through this date first format. But one of the things that we can do is that we can set the how would I call it? I think we can set the delimiter in terms of the difference here, what it follows here. I think we can set that. I'm not 1 minute, I'm coming. I think we should be able to do that. Okay, no, we can't. All right, so but basically this is how we change the dates format that we have. So now we have this, and so if we come back to our sales data to see if it has changed the format that we have, we see here that it has still not changed. So now, why is it that our date format here has been changed and it has not changed here? Now, if you remember the other time, we used the in place function on any of the changes that we do. We use the in place function. So now let's go back to the time, the date time colon itself, and see if we can use the in place function with it. So we say comma in place equals true. So when we run this, it says that what date time does not have any argument called in place. Now, how do we solve this problem? Because this looks like a problem. So now to solve this problem, we use the other method. And the other method is for us to say, we call this colon that we have, that we are changing the colon. Like, you know, we are changing the we are changing the data type on the other date colon itself. Now, what we would now do is we would say sales data, and we would create this colon. The column already exists. We would now say equals to this date that it has been changed to. And so when we do that, that would change the colon that we have. So it would how would I call it? Now it would overwrite what we have inside that colon. Do we get it? So now when I run this now, we would now see that our date format here has changed. Previously it was like this, right? But now it has changed like this. So we would see that from what we have done so far, we have been able to show ourselves two methods of updating a table. The first method is using the in place function, the in place argument, sorry, that comes in between a function. Where is this guy? The in place argument that comes in between the function. And the second method is for us to is for, okay, the in place argument that comes in between the function. And the second method is for us to literally state the column name that we want to replace, and we say it is equals to what we want to replace it as. Now, with this, we've converted our data type from, so when we run this now and see what is inside, we see now that our order date has changed from object to date time. Are we together? Now, the next thing we want to do is, so we've cleaned our data so far, right? But the last thing is to explore, right? So now, we also, before we now explore, we want to look into what exactly is inside each of these columns that we have, and if the column is needed. So if the column is needed, we will leave it. But if the column is not needed, we will have to remove it so that it does not affect our analysis. It does not make our table so bulky in terms of running analysis. So now, what are the columns that we need so far? From what we have here, we see that we have order number. Order number is quite important because it is a primary key in identifying our sales record. Also, we might also want to use it to see which order number had the highest number of sales in terms of quantity ordered or something. So we cannot remove order number. Quantity ordered, we can't remove it. Price each, we cannot remove it because it is the price of what was bought. Order line number, we really do not need to remove it because order line number tells us a lot of things. It tells us if the number of orders that were inside that order. That's another thing. So, but sometimes we can also remove it if we really do not, if we are not performing any operation on it. But we can leave it if we want to say, what is the average number of orders that customer place in their orders? Do we get it? So for instance, if we have one order, this is one order, right? But inside this one order, we have two orders inside it. So if we are looking at order number in terms of our analysis, the average order would be the total order is 2,823. But inside our order, actually, the average order number, the average order quantity, is it quantity we call it, or volume? Yeah, the average order volume would be what is inside this order line number. So when we are performing our analysis, depending especially on how deeper we want to go, we might have to leave the order line number. Please give me a moment, please. All right, yeah. So for me, I would want us to leave our order line so that we are able to perform more in-depth analysis on what we have so far. Now, the next thing we are looking at is sales. We've said this sales is our total sales. Yeah, but I want to do something. Okay, let's leave it, don't worry. So we have order dates, we have status, we have quarter ID, which means this order was in the first quarter and in the second month. This is useful for us to perform performance analysis on sales records. So we are able to see which what's it called, which quarter does the business performs better, so we can do all of those things. Now the next one we have is year ID. Okay, now we have product line, so we do not have product line showing here, so we want to check what exactly is inside product line. So let's come here and say sales data, and we check our oops. So okay, so in the product line we are able to see, okay, the type of products that are inside all of this, so we can check the unique values that are there. So we have motorcycle, classic cars, truck and bus, vintage cars, planes, ship, and all of that. So this is something we would want to look at in terms of the product line. Now, in terms of MSRP, we checked it the other time, and I'm not sure if it's something we need per se, but to avoid issue, let's just leave it. Now, the next thing we want to see is product code. For product code, this is useful for us because we might want to check the products that we have. But let's try to do something. We can also try to compare the product code if it is equal to the product line that we have. Now we see here that we have a lot of product code, and the product codes can be attached to multiple product codes can be attached to one product line. So it means that the only way for us to identify a product that we have here is our product code, because we don't have any product name on this record, and we want to check, okay, which products sold the highest number of which sold the most within a particular period. So that is something we also want to check. Now the next thing we want to look at is customer name. It is best we leave customer names, especially when we are performing sales analysis. But do we need our customer phone numbers in our analysis? We really do not need it. We can always go and check the customer's contact from the database after performing our analysis. We really do not, except for certain situations. Except for certain situations where the customer contact might be needed in our analysis table, depending on who we are creating the report for. But for us, in this analysis, we don't need it. So we'll be dropping our phone, this customer phone phone number. So let's just, so to drop also, all we just have to do is say drop, say columns equals to, and we have, so now the next one we want to look at is address line. Do we really need address line? Not really also, because we are not performing anything with the address line, and most likely most times also the customer name is also attached to this one address line. So except for certain situations where you could probably have a customer or multiple customers having the same address. But for us in this analysis also, we really do not need it. So we'll be dropping also address line, despite it being important. But because of the type of analysis we are performing today, we really do not need it also. So we need city. We want to see the cities with the most sales and all of that. We need country, we need territory. Now, contact last name, contact first name, we really do not also need this, because these are things that go along with the customer name in terms of when we create certain reports for different stakeholders. So in my opinion also, we really do not need this. So we can remove this, and so now we want to drop all of these columns, not because they are empty, but because we do not need them. So there's a difference between dropping a column because of the because of null value, and a different and dropping a column because it is not needed in the analysis. So but we can also decide to leave them if we want. Also here we'll just say in place equals to true, and then we say sales data dot head. So now we should have okay. So we have all of this now. All right, so we have all of these columns, and we can begin to perform certain analysis on our data. Now, the next thing we want to do is basic data exploration. Now we want to see how do we explore descriptive statistics and all of that. Now, for us to start perform descriptive statistics and analysis, there is a function for that also. So all we need to do is, sorry. So all we need to do is we call the function called describe. So this describe, all it does for us is, all it does for us is it describes the data that we have, and we are able to see certain things from here. First is it describes everything that has to do with numbers, so we can see how many records do we have, 283, 283, 2823, and all of that. It gives us the average time. I'm sorry, the average. So the average order number that we have. Obviously, we don't really need this, but the average quantities that we have, yes, is 35. So it means that on average, each customer buys 35 of the products that they order in terms of quantity. We are able to see the average price of the products that are being sold. We see the average order line. So now we see the difference between the numbers of order that we have and the average order line, the way I mentioned the other time. So we are able to see that, okay, each customer places on average 5 or 6 orders in their order. So these are some of the things we want to see. This is the average sales value in terms of products that are being sold. And what else? We see the average time exactly. So even we could see average time. So it means that on average, orders came in about like 2004, and on average, the quarter that makes most of the sales is about between the second and third quarter. Now, all of these descriptive statistics that we have here, we would be able to see them better when we now perform descriptive analysis, because this is just statistics showing us calculation. What is the maximum order number? What is the average? What is the this? What is the that? But when we now go deeper in terms of performing descriptive analysis, we will now understand better how all of the data that we have is being used. So if you have any question before we move to the last part of what we have, which is the selection and filtering, then we can continue. Any question? People have dropped off. But lastly, the last part that we have basically is just the selection and filtering. How do we filter data? how do we filter certain things that we have. The other time I showed us something about filtering when we were trying to pick countries that fell under that had no value for what's it called, for territory, something like that. So these are how we filter and all of that. Now, data selection in its own form goes to how do we select certain rows and certain columns. And the other time, I think I already showed us how we can do that using the column names and the iLoc. So these are some of the things we can do. So, but let's just go about with what we have in this data. So in this data, for instance, if I want to pick, if I want to select columns, all I just have to do is put the column name that I want to select. I want to select, let's say I want to select status, and I want to select sales, for instance. All I just have to do is sales. So when I do this, so it says status and sales. Something is wrong. What is wrong? Okay, I have to put this in double quotes. Now, we'll see here that when I tried using single quotes, it didn't work. Reason is because I am calling multiple column names. That is why it did not work. But when I try, so when I call multiple column names using a single quote, it's not going to work. But when I want to do call multiple column names, all I just have to do is use the double quote. And with the double quote, I can call different or more than one column in my column name. And for each of the columns also, we should have them in quotes. We should have them in quotes. So this way we are able to select. So another way to select what's it called, different columns or different so okay, yeah, I talked about columns, selecting columns. Now to select rows, I mentioned the other time that we use the iLoc function. So all we just have to do is say sales data dot. So if I come here and say iLoc, I can say, oh, which row do I want? If I say row, give me row 100. All it does is it gives me the data that is inside row 100. So when I kind of want to see what is inside each of them, this is the record that sits on index 100 that we have. So we see the order number, the quantity that comes with it, the average price, and all of that. So these are ways to do this. Now, also we can actually pick multiple what's it called, indexes, just the way we had multiple column names also. So if I have, give me 100 and 101. So we see we have ID 100 and ID 101. To make it quite interesting, let me pick ID 0 and ID 2822. So we see the first record. This is the first record. So when we scroll up and see, this is the first record we have, 10.10.7. So we see it here, 10.10.7. So this means that we can select based on rows also. So selecting records based on rows. So this is just how we do that using the column names and iLoc, as we previously mentioned. Now, Boolean indexing, how does that work? Now, Boolean indexing works along with Boolean indexing. Let's say, for instance, I want to pick all of the indexes that are zero, that are even numbers. Are we together? I want to pick all of the indexes that are even numbers. How do I do that? Now, to do that, all I have to just do is I would say Okay, so no, this is indexing first. So selecting index with criteria. Now, if I want to pick indexes, for instance, or yeah, indexes that fall under even numbers, how do I do that? All I just have to do is I would say date sales data. Now, when I come here and I do dot sales data, I can see inside there index. And what does this index tell me? It says start. I can give a range. I can give a range of the index I want to start from. By default, it starts from 0. And I can state where I want to start from. And I say, okay, give me index starting from 0 to 10 from in step 2. So I can just say, give me index starting from 0 and length of sales data and 2. So when I run this, so it says index is not callable. So let me go back again. So let me say 10 here and see what happened. Something is wrong. Oh, I have to pass this in a list and I have to use the range index. So I have to pass this in a list. Let me just say list. And I have to put this in a range index. What's this now? Something is wrong. Again, range index is not callable. Why is it not callable? It's supposed to work. This is supposed to work. I don't know why it is not working. This is basically supposed to work. So with this, I can literally return values that are in my what's it called, in even indexes or odd indexes. I don't know why this is not responding. I don't know why this is not responding. It says okay. I don't know why this did not respond here. But anyway, to explain what's it called, Boolean indexing. Now, Boolean indexing in its own form is, how would I put it now? Indexes colon or picks record based on index that fall or that meet a certain criteria. Now, this is like filtering also, but the other time we showed us. So can you mute yourself, please? So now, when we look at our sales record here, and we have sales data, and we want to look at a particular column. So let's say status. Are we together? Status. And okay, yes, status. We say so we want to pick where status equals to, let's say, shipped, or where status equals on hold. So when we have status, for instance, status, and we say equals shipped. So when I run this now, we see what we have here is a Boolean response. So this Boolean response now literally is used to identify, oh, this record in index 0 is true. This record in index 0 is true. In index 1 is true, and all of that. So this way, we can then use this indexing that we have, which is on the Boolean to now filter the table that we have. So now to now filter, all we now have to do, based on the condition that we have set, based on the condition that we set here, so we would now recall the table that we have, which is sales data. We put it in a square bracket and we put this Boolean condition that we set previously inside it. So when we run this now, this would return all of the records, all of the orders that have been shipped for us. So this way we can create a new table and say, let's say, shipped orders. And then we can perform analysis on shipped orders if we just want to look at the shipped orders. Are we together? So this is a way to filter a particular table. So if we also want to look at, orders that have not been, so let's not use orders again, let's use something else. If we want to look at products that are sold in, let's say, EMEA, for instance, we want to look at products that are sold in EMEA. All we have to do is we say EMEA, let's say orders, and equals to where territory equals to EMEA, and then we can check. So we'll see all of the orders that are here are for EMEA. So we see everything inside the territory is for EMEA. Now these are ways to filter. Now you can even filter on multiple conditions. Now let's say, for instance, we want to filter products that are sold in France and in Paris, meaning the city is okay, automatically the city is Paris, it will be France. No, I don't want to do this. Okay, let's say we want to filter on products that are sold in Paris and in Madrid. Are we together? We want to filter on products that are sold in Madrid and Paris. How do we do that? Now, to filter on such condition, what we'll do is we'll say, so let me come here first. So let me remove this also. So we'll state that our city equals to Paris and also city. Oh, sorry, we use or because we are picking any of the two. So we'll use or. Or is pipe. So or equals to Madrid. So when we run this, okay, it says there is a problem with our pipe. Okay, so let's use or. Okay, another one. So it says the true value of a series is ambiguous. Use a.empty and all of this. Okay, so now there's a problem with our condition that we state here. How then do we filter on these two? Now to do this, we would have to are we together? Okay. So now we have Okay. So, as we mentioned the other time, we have what's it called? The multi-dimension, the multiple conditions that we've set. So this now, what we are doing here is we are picking cities that are either Paris or Madrid. Now with this pipe, I used a single pipe the other time. I used a double pipe, supposed to be just one. So with this now, we are able to pick cities that are either France or Paris. Now to now see if what we've done is truly correct, all we have to do is we write sales data, and then we'll put what we have here in a square bracket. So when we run this now and we go to our city, all of the cities we'll be having will be either Paris or Madrid, and we can see all of the records here based on that. Now another one is if we want to see conditions that meet a particular filter. So for instance, I could decide that I want to see all of the orders that are from, let's say, Finland in 2005. Are we together? We want to see the orders that are from Finland in 2005. How do we do that? Now, same structure, just a little bit different from what we've done here. Now, what we'll do is we would say our country, yes. We look at country and we look at the year. So we have year equals 2005 and we have country equals to Finland. So when we want to do this now, we use the condition and for and here we use the single quotes. So when we run this, it says false, 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 false. Now when we want to see all of the records for this, we have okay, good. We have an error here. Okay, yes. Now we have records for the year 2005 and country is Finland. So when we look at the year, we see 2005 here, 2005. And when we come to the country, we see it's for Finland. So here we are able to see how we use the logical operator in Pandas, which is and here we use or. So this is where we'll stop for today. And so we can basically practice all of what we've done so far. And next class, by next week, we will be working on data visualization. So all of next week will be for data visualization, and we will be able to take care of what is left. So this is where we'll stop for today, and I would like us to ask questions and basically go and practice what we've done so far today. So any question?
Hello, sir.
Yeah, I'm with you.
Yeah, when we got data from web through HTML.
Yes.
So the data was messy. So you try to convert it to table.
Okay. Yes, the way the data came in, it it was like this. Like, okay, let it load. It was like this, and I said that we see there that it is in a what's it called, in a list or an array per se. Sorry, in a list, because it has